Space Agency of Uzbekistan, as you may know from the first session, is moving forward in evolving different actors in the space industry. But since today our session is remote sensing and GIS, I'm more concentrated on what we are doing in this technological sector. Specifically, I would like to put your attention to what we've achieved within the last, say, year after the launching of the space monitoring program. Okay, so let's give a short introduction of the Uzbekistan Space Agency. So we are a government entity under the Digital Ministry of Uzbekistan. We are working in different sectors, including remote sensing, satellite communication, navigation, space monitoring systems, legacy, information legal base for the space industry in Uzbekistan. We have external international partnership with a lot of countries, including agreements with several countries. You can see the slide. Also, we are actively conducting the international communities, such as we become a member of UNOSA last year. We are actively working in the UNSCAP and CIS, Intergovernmental Space Council, in particular case with space organization. Yeah. So, coming to the main topic, the state space monitoring program. We've launched the monitoring program at the level of the government. When the government is becoming a unique order, the executor is the space agency. Actually, we have the space monitoring center under the space agency, which are doing all the job. There is a 100+ team of HIS high-level specialists who are doing the monitoring program in terms of emergency, geology, ecology, water management, land relationship, forestry, and agriculture. We basically covered, if not the whole, but the most of active territory of Uzbekistan. We are working with most of the ministries of Uzbekistan. We've accomplished a number of projects. We've established geo-platforms, which we have already transferred to the ministries. And we are constantly given the analytics, this data, which are helping them on a daily basis to tune their actions and get the proper decisions. So, one of the main products I wanted to present today is our new development on the monitoring of the land usage. So from 2022, we are actively monitoring the land usage of Uzbekistan in terms of illegal building detection or similar stuff. But the problem was that by using the optical data, first of all, since the territory we are monitoring is relatively big, we're talking about 200,000 square kilometers, and collecting this kind of data within half a year or more was, first of all, expensive, and it required a lot of computing data and specialists. So we've switched to the different paradigm. We started to use the SAR data. So the idea comes from our next project that I'll show you. It's from the INSA algorithms. So we've developed a platform which is using the SAR data to detect any anomalies which are happening on the surface in the, let's say, time frame of 1 month. And we can detect any building or construction on the beginning level. You can see from the images that we have detected the buildings when the, let's say, the concrete is just built there. So with this, we are helping to our governmental entities, cadastral agency, and the others to detect the illegal actions before the civilians can finish the building and they can settle it. You can see from the right side that how fast the building can happen within like 3 months from the concrete until closing the roof, and the family is already there. And then it's always difficult to take them out of this building and destroy it. So by this system, we are helping to detect all these anomalies, all these illegal actions on a monthly basis, and to help the governments to act. Our next project we are launching this year is called Unified System for Subsoil Management. So from the last year, we are monitoring all subsoil, the mines for the violation of the licensed borders and detection of the illegal mines. But again, there was a lot of questions on what we can do to systemize and to bring, let's say, a digital solution to solve a number of problems in the geological sector. So what we did is, including the space monitoring, we also added the aerial monitoring. So this year, we are creating a topographic maps of each and every mine in subsoil in a 1,000 scale, digital DSM models, and parallelly we are creating a digital platform which is going to bring all the players within the subsoil. It is the miners, geology ministry, ecology, and the others. And all this data will be accumulated in one platform, and the platform will be the source to evaluate the actual excavation volume of the mines in each mine. By this, it will help the government to have the exact estimation of how many cubic, let's say, meters or how many tons of the ore or the mines were excavated within the mine, within the time frame, let's say quarter, half year, or 1 year time. And this is definitely can help to increase the taxes, can help to see what is happening in terms of ecological issues, because sometimes the miners, they don't take care about these ecological rules, and they're digging deeper and wider than they like. And by this, they are violating all these rules. So this is also what we are launching. This is going to be launched by the end of this year, and for the next year, all the miners are going to be working with this system. And the Space Agency is going to be a tool to monitor, to make the DTM, and to give these evaluations. The next project we are implementing from this year again is regarding the water resources. As you know, from the ecological topic, the water is becoming a huge agenda, and especially in the region of Central Asia, the water resources are limited, and we need to be very careful on their usage. As a contribution to this topic, Uzbekistan Space Agency, together with the Water Ministry of Uzbekistan, is launching a project for the monitoring of the water usage in a parcel. The idea is to use the satellite data from different constellations, and by using the algorithm of evapotranspiration to make the evaluation of how many cubic of water was used in each and every parcel. By adding our agricultural monitoring, we can determine what kind of crops are planted in this parcel. We know, let's say, the limits of what should be the consumption of the water, and we can be able to see the actual consumption of the water. By this, we're going to be solving different problems. First of all, the main one is a proper distribution of the water throughout the region. If the region will have the equal distribution of the water, overall the harvest is going to be more than we expected. The next one is, of course, the limits. By finding the champion farmers which can use less waters or can use water-saving technologies and receive more, let's say, yield, we can find these champion farmers, and by expanding their experience, we can bring this, I would say, high-tech or new farming algorithms to Uzbekistan. And of course, by using this technology, we can digitize all the water infrastructure which we have in Uzbekistan. You can see from the images and the slides we have, we are already mapping all the irrigation lines, channels, distribution lines, and the others. The next topic regarding the water resources is the monitoring of the water reservoirs. So we are using two technologies. One of them is a SAR technology with our Japanese partners, company Sinspective, also within this panel. We are together monitoring the displacement of the dam and also the equatorial of the water reservoirs. You can see from the two table graphics that below you can see how the water volume was changing within the 4 years, and by seeing seeing the sun data, we can see that there is a correlation between when the water volume in the dam was full, also the displacement on the dam side was also exceeding. So we can see the correlations. We passed all this data to our water ministry, the seismology ministry, and the other entities which are responsible for maintaining of these dams, and they found this data very useful. On the left side, you can see that there is a DSM of the water reservoirs to have the exact numbers of how many water can the water reservoirs accumulate. We created, by using different technologies, UAVs and multi-base sonars, we've created the digital surface model of the water reservoirs. And by using the GIS, we can animate in which level, how many cubic meters of water can be filled. One also interesting topic regarding the ecological sector, specifically the forestry. We are using the GIS and remote sensing for mapping the forestry, the trees, and monitoring in the period what is happening, especially in Uzbekistan cities. From this slide, you can see that we are monitoring from 2022, and we see that, for example, in Tashkent, the capital of the city, there is a degree of decreasing of the degree of the greenness to 12%. This is the data which is very crucial for the ecological ministry, the forest ministry, as well as the governors of Tashkent to further plan how they need to manage the city and overall the situation in Uzbekistan. All of this could not be happening without the AI technologies. Within our team, we are strongly committed to use the AI and machine learning technologies to move forward with these big challenges and data processing. You can see that we are using all of them, including on each and every application we've showed before. We are using it for super resolution management, for specific class object identification, tree identification, or you name it, any applications we are using the AI. We see that the AI is bringing a huge value for the digitalization for our specific applications. And we are going to be strongly committed to further develop this technology in our team. So, thank you very much for your attention. If you will have any questions, we'll be happy to talk to you on our staff. Thank you.